Lesson 3.1, constant rate of change. The objective is for you to be able to identify proportional and non-proportional linear relationships by finding a constant rate of change. And you should write this down. Linear relationships are relationships that have a straight line graph. Okay, linear relationships are relationships that have a straight line graph. Here is an example of a relationship. Is it a linear relationship? We don't know. We will find out by looking for or discovering the rate of change to see what the rate of change is. And the rate of change is just basically the differences. It's a ratio or a fraction of the differences. So let's look at this table right here. We have number of songs at the top, and we have time in minutes at the bottom. So we have 0 songs, 2 songs, 4, 6, and 8 minutes, 0, 1, 2, 3, 4. So how, or in this relationship, and it looks like it's in increasing order. So we have 0 to 2. So to go from 0 to 2, there's a difference, or it changes by adding 2. And from 2 to 4, again, this one changes by adding 2. Going from 4 to 6, the difference is adding 2, and the difference from 6 to 8 is adding 2 as well. So the number of songs, the difference here, or the change here, is it goes up by 2 every time, which I denoted by adding 2 or plus 2. On the bottom, the minutes are going up by plus 1. Plus 1, plus 1, plus 1. And like I said, the rate of change is a ratio. A ratio is a fraction. We can put the difference, if you notice, between every time we go up 1 minute, we go up 2 songs. 1 minute, 2 songs, or we could say every 2 minutes, 2 songs, it goes up 1 minute. And we can write that or represent that as a fraction of 2 over 1, which means 2 songs per minute. When we have a ratio like this that is the same between any pairs of points, this is known as a constant rate of change. And since this has a constant rate of change, it is a linear relationship, because all linear relationships have that constant rate of change, meaning the ratio stays the same no matter which two pairs of values we use. We have that same consistent ratio. In this next example, we are asked to find the constant rate of change. So this is a linear relationship because they say find the constant rate of change. This situation, we have a table of values that is vertical. So the first one we saw was horizontal, side to side. This one is up and down. We have number of transactions. So this is like for a bank. So here we have 3 transactions, 6, 9, and 12. And the balance, that's how much is in the account. So we have 170, 140, 110, and 80. So we want to see how does each of the parts change. So we can see how the number of transactions change. If we go from 3 to 6, how does that change? It is being added by 3. 3 plus 3 is 6. How does it change from here to here? It's plus 3. And we see that on the left side, the number of transactions, the way it's changing is being added by 3. On the right side, the balance, how is that changing? It goes from 170 to 140. So that one is actually going down. So if it's going down, it's changing by being subtracted. What is it being subtracted by? Well, the difference between 170 and 140 is 30. So it's subtracting by 30. And let's see if it holds true. 140 take away 30 also gives me 110. So it looks like it's changing by subtracting 30. And then lastly, from 110 to 80, we subtract 30. So we know that the number of transactions is changing by a positive 3. The balance is changing by subtracting 30. And again, the constant rate of change would be the ratio of the differences or of the changes. So how do we know which change goes on top and which one goes on bottom? Well, the one that goes on top is the one that's being affected by the other, almost like how we say independent and dependent. The balance depends on how many transactions were taken. So we're going to put the transactions on the bottom because that's the thing that affects the balance. So the change on the balance, so we're going to say transactions on the bottom. Here I have some space here, transactions. And it's going on the bottom, and on the top we're going to have the balance in money, balance in money. So if we write the ratio, the change here is a negative $30 for every 3 transactions, and this is a fraction, so we can simplify it. So we can actually divide this by 3 on the top and bottom. We get negative 10 over 1. And so what does this mean? This ratio means that the balance decreases by $10 for, that's the wrong for every 1 transaction. And that will be our constant rate of change for this relationship. This is how we say it as a sentence. This is what the numbers are right here, or just the ratio. Here we have another relationship, but this time the relationship is represented as a graph. And this graph is number of volunteers by time in minutes. And so we can still use this information to find if there is a constant rate of change, to see if this is linear. It looks linear, but we can find, if it's linear, we should be able to find a constant rate of change and seeing how does it change. So we're going to see how the time changes over the number of volunteers. So if we go from one dot to the other dot, we can say here, if we go down, the time changes by how much? The time is changing here by, from 80 to 60, it's going down by 20. And then in the volunteers, if we started at 8 and we're going to 60, we're going this way. We're going how much? We're adding 8. So we have 20 over 8 right there. If we go from this dot down to that dot, it's going from 60 down to 40. So again, it looks like it's going down 20, just like it did before. And then to go from this part 16 to 24, that is plus 8. So do we have a constant ratio? It looks like it because it says negative 20 over 8, negative 20 over 8. So let's write that as a ratio. We can write negative 20 minutes. So it goes or decreases by 20 minutes every or per 8 volunteers. Now, can we simplify this? Yes, we could simplify it. 20 and 8 can both be divided by 4. So if I divide by 4 here, let's see, okay, I still have some space. Divide, I have negative 5 over 2. So again, we can still say it the same way. It decreases, the time decreases by 5 minutes for every 2 volunteers. And if we want to find out how much for 1 volunteer, we can actually divide the 2 into the 5. And we can say 2 goes into 5 2.5 times. So we can also say for every 1 volunteer, the time decreases 2.5 minutes, or yeah. So any one of these ratios are equivalent. Depending on what question is asked will determine what kind of answer you want to give. Now we're going to explore proportional linear relationships. Here we have a relationship between Celsius and Fahrenheit, or degrees Celsius and degree Fahrenheit. We can check to see if it is a linear relationship, or confirm that it is a linear relationship, by finding the rate of change to see if the rate of change is constant. So let's do that first. So the rate of change will just be how are the Celsius degrees changing. They look like they're being added by 5 each time, which you can confirm. Plus 5 is like counting up by 5. But what about the degrees Celsius? How are they changing? If I go from 32 to 41, that looks like it's increasing by 9. 41 to 50 is also increasing by 9. So they're all look like they're increasing by 9. So it looks like that we do have a constant rate of change. So the constant rate of change is 9 degrees Fahrenheit over 5 degrees Celsius. So we know that it is a linear relationship because it has the same ratio between any two points. But now we want to check a proportional linear relationship. So to be a proportional linear relationship, it has to have this constant rate of change, but it also has to have a constant ratio. And that ratio comes from putting the numbers over each other and seeing if the number or these ratios actually equal each other. And since I wrote it as Fahrenheit in the numerator and Celsius in the denominator, we'll do the same thing here. Fahrenheit over Celsius. So what I'm doing is going to be checking if the ratio is constant. So we'll start with the first two values right here. The first is 32 over 0, the 32 degrees Fahrenheit over 0. And this is actually undefined, so this doesn't even help us at all. But let's look at the next one, 41 degrees Fahrenheit over 5. And we say, what does that equal? We'll come back to that. Okay, so 5 goes into 41 8.2 times. Let's go to the next one. That'll be 50 over, this is the same ratio, 50 over 10. So 50 degrees Fahrenheit over 10. If I divide that, that's going to be 5. So far the ratios are not equaling. We had undefined, we have 8.2, we have 5 here. Let's go to the next one. No. So that's enough. Once we check if there's any differences, then the ratio is not constant. If we did get the first two were the same, we would check a third or a fourth just to make sure, because you want to check enough times to make sure that the ratio is constant. But in this case, the ratio is not, so this does not fit, or this is not a proportional linear relationship, but it is a linear relationship. So it's a linear relationship, but non-proportional. Okay, so it's a linear relationship, but not proportional. Okay, so in order to be proportional, these ratios have to be the same all the way through, or constant, and it has to have a constant rate of change that is the same throughout. So it has to have both to be linear and proportional.